Hi, I'm Dan Cassar. I'm a tabletop game designer, originally from New York, now based in Philadelphia. And I'm going to be talking about how I use digital tools to help me balance the Rochester Draft in Cavemen, The Quest for Fire. Drafting is one of the most fundamental game mechanics out there. After all, we all remember picking teams for kickball in the schoolyard. But in the world of modern board games, when people talk about drafting, what they usually mean is a particular kind of card drafting that I call pick and pass. The way it works is this. Each player is given a hand of cards. He selects one card from his hand and then passes the remainder to his left, simultaneously receiving a new hand from his neighbor on the right. Again, players pick one of the cards for themselves and continue to pass them on. I think it's safe to say that the prominence of this approach probably came from Magic the Gathering and its booster draft tournament format, where instead of building a deck beforehand, it makes deck construction part of the tournament itself. Each participant is given a booster pack. Players each open their pack, select a card, and then pass the remaining cards. Antoine Bauza proved how successful this mechanic could be when he won the prestigious Kennerspiel des Jahres, the German Expert Game of the Year award, in 2011 for his game Seven Wonders, which is entirely based on the pick and pass draft mechanic. But I remember sometime in the early 90s, I saw a group of players at a local game store drafting Magic cards in a way that I hadn't seen before. Instead of opening one pack per player and passing the cards, they would open a single booster, spread the cards face up on the table, and then players would take turns making their picks. I later learned that this was called a Rochester Draft, named for the city in western New York where the format is supposed to have originated. Widely regarded among serious Magic players as the drafting format that requires the most skillful play, an open draft plays quite differently from pick and pass. It turns cards into chess. It challenges a player to make the best decision based on what he has already chosen and what he has seen the other players select. Turn order becomes all important, and counter-drafting becomes a much greater factor. Because there's no hidden information, you can choose to thwart an opponent by denying him a card that he needs, but only if you're willing to sacrifice one of your picks to do it. Cavemen, The Quest for Fire is a card drafting game I designed based on the Rochester Draft that was published by Rio Grande Games in 2012. Players bid for turn order before drafting cards to contribute to their tableau that represents their tribe. Combining an open draft with an auction creates a game experience that can be highly competitive without the need for direct conflict. Players take the role of tribal leaders and compete for scarce resources, such as dinosaurs to hunt, cavemen to recruit, and inventions to discover, vying to be the first to invent fire. Gameplay is organized as follows. Each turn, a number of cards are drawn face up into a common card pool. Then the players use teeth, representing prestige amongst the tribes, to bid for the conch, which is the first player token. After the bid, players pay food for the cavemen in their tribe to keep everyone alive. Then, starting with the conch holder and proceeding clockwise around the table, players take actions that allow them to draft cards from the pool, and then some of the remaining cards are discarded and the pool is replenished for another round. So the challenge was how to achieve cost and reward curves that not only kept the pace of the game moving forward, but also created opportunities for players to compete meaningfully in a game that used resource denial as its primary means of player aggression. For example, suppose we're early on in a game with 3 players. Abe has the conch at the start of the round, and if no one bids, he will go first. He's trying a technology-focused strategy. Since invention is the way to win the game, it's very efficient. But it can be hard to keep your tribe fed, and starvation can ruin your plans. Brenda sits to Abe's left. She's trying to pursue a strategy that relies on foraging. It's slower but safer strategy than hunting, and also gives her the freedom to go after certain inventions. Chris is the third player. He's pursuing a hunter-based strategy that ensures that his tribe will be well fed, but it might be hard for him to compete for special abilities later on in the game. In this spread, the most interesting card is this one, Baskets, which is an invention that grants its owner a considerable bonus to their foraging score. Obviously, any of the players would derive a benefit from this card, but Brenda would benefit most since it suits her strategy best. Abe bids first since he starts with the conch, but he decides to pass since he thinks that the other players will bid, and in Cavemen, you are allowed to jump back into an auction even if you passed in an earlier round. Brenda also passes because she's betting Abe won't draft the card that she wants. Chris decides he can't take a chance, and he bids 2 teeth to gain the conch. He wins the auction and drafts baskets so that Brenda can't get it. Moments like this are where the fun of the game really come from, and they require a number of conditions to be met in order for those situations to emerge. To create that tension, players need to have both the desire and the ability to be in the bidding. And in Cavemen, that means having sufficient total skill to make use of the card in question, as well as enough teeth to make it worthwhile to participate in the auction. In order to achieve this balance, I went through a huge number of evolutions of the deck before settling on the one that made it to print, and I was only able to manage that complexity with the help of technology. I started writing code on my Commodore 64 when I was 8 years old, and I've been writing software professionally for the last 15 years. So I suppose it's almost second nature that for me to record the information related to my games, be they analog or digital, in a computer-readable format. I chose to use a form of loosely structured data called XML to represent the data. XML, Extensible Markup Language, was designed to be both human and machine readable and to permit evolution over time. Data elements are represented as tags with names and values that you can expand on arbitrarily to suit your needs. Since the data was human readable, I could work with it without any special tools, just a text editor like Windows Notepad, and it allowed me to quickly add and remove cards. And since it was machine readable, I could use it for all sorts of automation, from printing my prototype decks to running scripts that exercise different play scenarios. Over time, however, editing the document by hand became cumbersome, and importing the data into Excel, while helpful, was a tedious manual process. So instead, I developed a piece of software that worked much like Excel, but used my XML document as its data source, and would save a copy of the document every time I made a change. This offered a number of key advantages. For one thing, this automatic version tracking ensured that I never lost any of my ideas. I could always go back to a previous revision. Over the 2.5 years I spent working on the game, I created more than 450 versions of the deck. Sometimes they worked, but more often they didn't. If I decided I didn't like the direction things were going in, I could simply go back through the history of the data and carry on from an earlier version. Additionally, the flexibility that I had in adding and removing fields allowed me the freedom to discover over time what data was important to track and what was not. As I conducted playtesting, I went back to my document and tried to incorporate what I learned. Sometimes I needed to tweak a cost. Sometimes I wanted to change the wording on a card. But just as often, I was trying to capture data that was beyond just what appeared on the physical card. I wanted data about how that card affected gameplay overall. I wanted to understand how each card fit in, and which players selected them, and at what time. Since there was no strict structure to the data, I could make up new fields as I went along, and I could remove them later without causing problems if the information didn't prove valuable. This allowed me to incorporate playtesting metadata directly alongside my card data, so that I could then edit and analyze all of it using the same tool. And this was how I identified the 3 core strategies that players generally followed. I noted the number of cavemen that a player had and of which types at the time that an invention was taken, and over time, certain patterns started to emerge. The hunter strategy was characterized by selecting additional hunters early and gaining an advantage in food and teeth. It's straightforward and effective, but it means that the player cannot leverage many of the higher cost inventions in the game. The inventor strategy usually meant taking a thinker as your first recruit and then carefully managing your food supply while amassing inventions that only you could use. It has the advantage of being efficient, but thinkers can't help you feed your tribe, so food often becomes a problem. The elder strategy focuses on foraging as a safe food supply and can be dominant if it manages to acquire one of the few key inventions that help it gain teeth so that they can compete for fire at the end of the game. Once I had made that discovery, I started including the strategies in my data. When I designed a card, I would tag it with the strategy I was gearing it towards. And then after playtesting, I would add additional information about the strategy being used by the player who drafted it. This helped by not only making sure that the cards were doing what I designed them to do, but also helped me make sure that I could easily see how many of the cards I had intended to help each of the 3 major strategies. If I added or removed cards, I could make sure that the strategies remained relatively equally supported. I remember one time in particular where my playtesting data showed its value in an unexpected way. I had been taking the game to designer meetups for playtesting sessions, and the game was generally well received. But there were a number of questions about the balance of the inventions in the game. So I had been steadily tweaking costs and swapping out cards, and gradually a strange thing happened. Players had stopped engaging in the auction. Everyone was content to simply let the conch pass around the table and take what they could. At first I thought this was some sort of anomaly or something particular to the way the cards had been drawn. So I kept going the way I was going, trying to achieve a perfect balance between costs and benefits for the inventions relative to one another. But looking back over successive versions of the data, I saw that during the process of balancing the invention costs, I had gradually increased the cost for the most useful inventions, thus putting them further out of reach for more players for more of the game. As a result, all the tension was gone. Somehow, more balanced costs killed contention. That's when I realized that in order to make the game fun, I had to create sufficient opportunities for players to compete. Leveraging the data that I had gleaned from playtesting, I identified inventions that were suited to multiple strategies. Then, I made those inventions intentionally undercosted so that players would bid for the opportunity to draft them. For example, the feast card allows a player to convert food into teeth. This, of course, only works if you have enough food to spare, so it's not suitable for a player focused solely on invention. But it does work well for other players that can gain a surplus through hunting or foraging. If it appears late game, this is a card that is intended to be bid over because it's mathematically superior to all other ways of gaining teeth in the game. Similarly, medicinal herbs greatly reduces the chances that you will incur losses when you go hunting. This works well for both hunters and inventors because both of those strategies rely on hunting to gain food. It's got the lowest possible cost, so anyone can take it, and it's more useful than many other cards at the 2 and 3 cost levels, so this encourages players to compete over it. Tabletop designers may not always think about the ways they can leverage technology to help them enrich an analog experience. Balancing a set of cards can be a tremendously tedious task. A single design decision can cause changes that ripple throughout the entire deck as cost curves shift and card counts are thrown out of balance. Having software to make this more manageable encouraged me to take more chances, make bigger changes, and ultimately led to a better design.
Thank you, Dan. Wow. Dan, it's a crime that you're not working in the digital game industry. I think we have a question over here.
Sure. So first of all, yeah, the tool is excellent. I built something similar, but I was using Google Spreadsheets, which does a lot of this stuff. But what I found was, and you can export things, export XML, you can do the revision history. But what I found difficult was figuring out a way to actually visually display these cards. I used HTML, but it's really hard to get that to print properly. I'm just wondering what kind of tool you built or used for that display.
Yeah, that's a problem that I worked on. I went through a few iterations on that. First, I tried SVG, which turned out to be really difficult. Don't recommend that. So I tried using my second, more successful attempt. I leveraged an external tool called Nandek. If you're a tabletop game designer, you might know this one. It's actually scripting software that you write code to generate your cards. So out of my tool, I would generate a script for Nandek, and that would do so I could leverage it to generate my cards and print them. So that worked a lot better.
Nandek, cool.
Yeah.
Thanks.
So whenever I'm building tools for the game, I'm thinking always about how I'm not spending time making my game. I was wondering if you measured the amount of time you invested in this tool, because it seems like all of your work Like with a video game, usually when you work on your editor, you're also like salvaging some of that technology for your game. But it seems like in this case, there's absolutely no overlap.
Yeah, perfect test case for the tool has nothing to do with the production.
Right. And was there anything that you did to like make sure that the features you were adding were paying off on like an individual basis? Because obviously the tool paid off, but there were a lot of like, seems like luxury, quality of life stuff in your tool. Did that work out well?
Yeah, I would say that without the benefit of the tool, I wouldn't be able to surface the same data that I was able to see with it. It was kind of the thing that started as a hobby project, started very small. Like I said, I was originally just tweaking the XML by hand in Notepad. And then I was like, well, I'm a programmer. I can do better than this. And so I did. And, it evolved over time. No, I never measured how much time I actually spent on it. Like I said, it was kind of, grew up with the game. Over time, I just added more and more features. And as I said, I spent years working on the game. So it was... I never really paid attention to how much time it was. Because it was fairly generic. I didn't feel like it was wasted time because I am using it for future games as well.
Cool. Thanks.
Thanks. Let's take one more for Dan.
Thank you. How much of the analytics stuff you got was out of the running you mentioned software to run games following certain strategies. How much would you say came from that versus how much you got from watching and I presume recording human play sessions? Did you record those and feed it back into analytics?
I recorded it in that I watched and then put the data back in. So I did do a certain amount of scripting and automation, and what that allowed me to do, what that was generally to do was to just run algorithms to check my math. Once I was comfortable with that, then it was pretty much all hand play testing that gave me the best results.
Cool. Thank you.
All right.
Thank you, Dan.
Thank you.